Okay, so for this signal, I thought to make a few sketches. Let's start with the first one, which is g t minus 4. This simply means just move the graph by 4 points to the right. That's just what it means. So it's going to come minus 4 plus 4. I'm moving it to the right by 4 points. So this is going to become 0. Then the next point is 0. So that will be 0 plus 4 equals to 4. And the last point is 2. So 2 plus 4 equals 6. So this graph is now going to become, starting from 0, is going to go up to 4. Then it's going to fall down, this time to 4. Then it's going to go up again to 2. Time is going to fall down to 6. So it's going to complete this 6. That's going to be for the first graph. Now for the second graph, which is g t over 1.5. So this is called a stretch. We're stretching the graph. If I'm to write this, this should be g 2 over 3. So in order to do a time stretch, we are going to basically multiply every single value here, minus 4, 0, and 2, by 2 over 3. So for the first one, minus 4 times 2 over 3 equals to, so this is basically called time stretching. We're basically going to stretch the graph. So we're going to multiply every value, that's minus 4, 0, and 2, by 1.5. So it's going to be minus 4 times 1.5, which is 6, minus 6, sorry. Then 0 times 1.5, which is still 0, and 1.5 times 2, which is 3. So this graph is then going to become, starting from minus 6 this time, it goes up to unit 4, then it falls down to 0, then it goes up to unit 2, and then it falls down to 3. So this is going to be this graph. Now moving on to C. So now for this one, g 2t minus 4. There are actually two ways of solving it. Sometimes I just move to the right by 4 and then compress the graph, because 2, when it's 2 times the time, it's called compression. So for this particular one, you can do it in two ways. You can choose to separate the graph as g 2t minus 2. You can see it as they did here. Or sometimes I just move the graph by 4, and then this is called compression. We're compressing the graph. So you divide by 2. So I move to the right by 4 units and then I compress the graph. But you can also do this also. This one, you have to first perform the scaling function, that's the compression, before you do the delay. So focusing on this one first, we have to compress the graph by 2. So that will be minus 4 divided by 2, as equals to minus 2. 0 divided by 2, that's 0, and 2 divided by 2, that is what? 1. And then if you have to delay it by minus 2, that means you're going to basically shift the graph to the right by 2 points. So it's going to be minus 2 plus 2, that's equals to 0. 0 plus 2, that's equals to 0, and 1 plus 2, that's equals to 3. Sorry, this is 2. So the graph is now going to be, starting from 0, it's going to go up to 4 units, then it's going to come down to 2, then after 2 it's going to go up to 2 units, then it's going to come down to 3. Then you can do it this other way. Simply move to the right by 4. If you move to the right by 4, it's going to become minus 4 plus 4. So start from 0, 4, then 6. And then if you compress it by 2, it becomes 0, 2, and 3. Same thing. So I don't know, I prefer this way to be easier. Now for the last one, which is g2 minus c. This one is a bit confusing. You have to rearrange it. So it's going to be g minus t minus 2. Now you can really see what's happening. So you have to flip the graph by minus t, then delay it by 2. So for the flip, basically minus 4 is going to flip to become 4. 0 is to 0, and then 2 is going to flip to become what? Minus 2. And then we now have to shift it to the right by 2 units, right? So 4 plus 2, that will be 6. 0 plus 2, that will be what? 2, and minus 2 plus 2, that's what? 0. So our graph is going to look like this. So starting from 0, it's going to move up 4 points, because the first value there is 0. Then it's going to come down to 2. That's our next point. Then it's going to go up to 2 units and then come down to 6. So it's going to be 0 to 6. Obviously, this is not drawn to scale, but you get the point. Thank you for listening.